think that in general, plotting is a very useful skill throughout math and science and also for the CLEP College Algebra exam. So I think that these are some nice visualizations to commit to memory. So here we're looking at the plot of the function y equals 2 to the x. Okay, and what kind of behavior are we seeing? So we're seeing that as x becomes more negative, my values approach 0. And as x becomes larger, I'm blowing up very rapidly towards infinity. Okay, so this has rapid growth. Okay, and in fact, this rapid growth is so ubiquitous in mathematics, it's sometimes just called exponential growth. Very, very fast. If you say something is growing exponentially, you're saying that it's growing extremely rapidly. Okay, and we can see this by just evaluating some values here. How fast is it blowing up? Well, it's essentially doubling, right? So if I have, let's say, -1, we get 1/2. 0, I get 1, of course. 2, 4, 8. So it's really growing quite quickly here. Okay, so it's nice to have this mental picture of as I move towards negative infinity on the x-axis, I'm going towards 0. And as I move towards positive infinity on the x-axis, I go towards positive infinity very, very rapidly. Okay, another nice picture is what happens if I plot y equals 2 to the minus x. Well, we'll discuss sort of general transforms like this where I replace x with minus x. But in this case, I flip around the y-axis and I get something that's the exact opposite behavior. Okay, so in this case, as I move towards positive infinity on the x-axis, I'm decaying towards 0. So I'm shrinking very rapidly. And then as I move towards minus infinity on the x-axis, I have growth. So there's decay over here, growth over here. And again, your decline is sort of very rapid here. Okay, so this model is sometimes called exponential decay. Okay, so again, it's sort of ubiquitous in math and science. One of the most kind of fundamental contributions of this theory towards physics is in discussing like the decay of radioactive substances. The amount of radioactivity that remains after a given time is governed by this type of decay model. So I'll just make a remark for those of you who are inclined towards physics that you can think of this as the decay of radioactive material is governed this way. I mean, many, many other examples, but this is sort of one that is particularly relevant. Okay, and again, we can sort of get a picture for this either by remembering the sketch or by plotting some values. So let's say we'll do -1. Well, then I have 2 to the minus -1, so just 2. 0, I'm at 1. 1, I'm at 1/2. 2, I'm at 1/4. 3, I'm at 1/8. So I really am converging very rapidly to 0. Okay, the amount of stuff that I have, if this is a model, is going to 0 very, very quickly as x goes to infinity. So this is, I think, another nice picture to have in mind for the CLEP exam.